I'm Tiffany Trader, Managing Editor of HPCwire, and here with me today are Satoshi Matsuoka, Director for the RIKEN Center for Computational Science, and also joining me is Koduri, Senior Vice President and General Manager of the Accelerated Computing Systems and Graphics Group, AXG, which you can see on his jacket, at Intel Corporation, and we're all together at SC21 in St. Louis. So we're going to have a little discussion about what we're doing here at the show, and then what's we're looking ahead to in the future. You know, here we are on the eve of exascale, the cusp of exascale, and you know how did we get here, and how are we going into the future, and what are the next steps? So, Satoshi-san, yes. You are the innovator and the designer for one of the top system, Fugaku system, which has been the #1 system now for 4 cycles of the top 500 list. So you've gotten 4 of those #1 certificates, but you've also gotten the, I believe, #1 on HPCG, and I believe the HPL AI with already some exascale results on that. So how is your show going here at SC21?
Well, firstly, you know, it's live, and being live, you realize you get a lot more interactions than you would otherwise get on Zoom. And of course, like interaction we're having here, of course, was very careful COVID. You know, I'm facing this way, not to bombard with my droplets. But of course, it's been quite an experience trying to demonstrate what Fugaku can do, but also getting a lot of input for our future directions, talking to various institutions, researchers, being reunited with our research colleagues, as well as being able to meet the luminaries like Raja to really discuss intensively about where we would go from here.
And Raja, you and your group have been hard at work on the Ponte Vecchio GPU, which will be the centerpiece in the Aurora supercomputer, one of the first US exascale systems coming online. And you've been here at the show. You and your colleagues have been talking about the Ponte Vecchio, releasing just a few more details about that, and also talking about One API. So how's the show been going for you?
You know, first off, I'm super glad to be here live. I came to the show, frankly, because a lot of our partners, customers, and you know, folks like Satoshi-san traveled all the way here. So I couldn't let go of the opportunity to meet them all face-to-face and live. Many good interactions, as Satoshi-san said, nothing like, you know, face-to-face interactions and you know, being able to discuss ideas for the next generation and where things are going over the next 5 years, and so on and so forth. Congratulations once again to Satoshi-san for you know, the #1 supercomputer in the world. I'm hoping next year we will post some numbers. Some US exascale computers will go to the, you know, top of the list. We will see. And of course, you know, Ponte Vecchio has a big role to play in that, and we are hard at work. We have, as Intel, 2022 Sapphire Rapids with HBM, Ponte Vecchio, big products for us to ship and make it available to our customers. So in many ways, for us, this supercomputing is a precursor for 2022. 2022 is the big year for us. So things going well. Like I said, we have hard at work, lots of software work going on with One API to bring it up on new architecture, tuning, workloads, etc., working with our partners at Argonne Labs, enabling lots of HPC applications. You know, all the usual, you know, tough work, the steep hills to climb at the end to ship a product. That's what we're going through.
And Satoshi, what's coming up ahead for you at RIKEN with Fugaku and the ARM A64FX chip? What are your plans going into the future?
Okay, well, firstly, Fugaku is in production now. Have been in pre-production last year around this time of year. We went into production March of 2021, and since then the utilization has gone up steadily to the extent that now the machine is pretty full, which is quite amazing. You know, it's a 160,000 node machine with like 8 million cores, and it's not doing one big run, but across many applications we're getting significant utilization. So there is demand for exascale machines. We said when we embarked on this journey towards exascale, we said who's going to use their exascale capabilities? But now we have exemplar applications that utilize the entire machine, as instances. But also we have a group of application users, a variety of applications that basically fill up the machine on a regular basis. So, and we're constantly trying to improve the software set. Well, the hardware is pretty much set, but maybe there are some minor improvements we can make. But most importantly, we're still involved in really improving the software and system software applications, algorithms, and branching out to broader areas of utility of supercomputing to non-traditional areas, businesses, industrial usage, using what we call Society 5.0 in Japan, really transforming the society for sustainability causes. And then, of course, we will be using Koduri partly to investigate future architecture. You always build a machine, the next generation machine, using the current generation machine as a proxy and as a basis. So we are very busy embarked on these, and we are growing and hiring. So if you're interested, work with us.
Wow, here is your offer. Thank you. That's quite a vision, and it's really tied with helping society, which is what's the most important thing. So Raja, there were recently some changes with the HPC, the supercomputing group at Intel. What is your vision for the supercompute group going forward?
Yeah, we at Intel with Pat Gelsinger coming back have, I say kind of a newfound passion for supercomputing. And for us, supercomputing is not just only, kind of this big national supercomputers, big labs. We believe supercomputing capability need to be available to every human on the planet. And for that, we envision a future where exascale computing is accessible to everybody, which means it needs to come down in power, right? You need to get exascale in kilowatts, and the cost needs to come down. And we are busy at work creating technologies that integrate the components that make up this exascale supercomputers in 2022 and 2023, down to levels where every university should be able to afford an exascale computer in a few years from now. And we call that that's not just kind of bringing exascale down, but it will also enable the next order of magnitude computing for the the big computing centers. Kind of everybody shudders with the word zetascale. The next 1000x. But that's how the technology industry we roll, right? That's what kind of keeps us coming into work and creating technologies. So exciting phase with Pat Gelsinger back that we are all over supercomputing.
Wonderful. And so this zetascale, the next milestone, you've had some clear vision for what exascale means to you. Are you thinking about what zetascale means to you?
Well, when we met exascale, it wasn't about reaching limp factor, it's a flop. It's about reaching milestones of orders of magnitude performance increase over machines we had back in 2010. For us, it was a K computer. Of course, there were similar machines in the US, Europe, and so forth, like Jaguar and so forth. So by achieving 2 orders, or perhaps 3 orders of magnitude speed up, we may be able to really increase the application performance and portfolio. And just like I just said, we can even make it much more accessible, solving the world's biggest problem. So this is really the application first philosophy we have. And by that, what we aim to do is to really look at, revisit application performance. Because as much as you might think the supercomputing community is all about performance, how we actually measure performance and how we analyze performance is still actually not up there to my standards, even compared to some other engineering standards. engineering, there's other engineering disciplines which are much more disciplined. So, and so what we plan on doing is to really see what the status quo of that, and involving many people, our partners at DOE, Europe, and our collaborators and the industry, Fujitsu, Intel, other companies like your rival companies, to basically set standard, and then say, well, okay, then what if we increase the application performance? What are the requirements to increase the application performance by 10x, 100x? Then what kind of architects do we need? What kind of algorithm changes we need to do? So really be application first, and to drive for the next generation machine is our philosophy, and will be an action over the next 10 years.
Yeah, if I may add, the workload, understanding the current workloads that run on, that's about to run on all these big machines, and the Fugaku and the Satoshi-san's computers are already enabling a bunch of interesting studies, which we are following. His work, his analysis, and all. They are all going to guide us on how to architect the next generation machines. And real applications, there are opportunities. There are definitely opportunities for orders of magnitude, whether we can get them, 1 order, 2 orders, 3 orders. It all depends on what inventions we do and how much we understand. And as Satoshi-san said here, our understanding of workloads is still not very good, especially at large scale, right? We are just beginning that understanding, simulating all of these workloads. And I'm a workload person, so I'm super excited to kind of, dive into the details of those bottlenecks.
So I have one more question, but it's a big one. So we have with us one of the leading developers, the leading developer and champion for the ARM system, the ARM supercomputing system. And then we have over here Raja, who is the leading the design for the GPU accelerated supercomputer exascale system. Why are we together?
Yeah. You want to go first?
Well, firstly, you have to realize as supercomputer penetrates the broader IT market, the software ecosystem becomes really important. And of course, on the other hand, in order to achieve acceleration, we always want to have some sort of specialization or customization. Even A2FX, it's a standard ARM processor, but has acceleration inside the chip. It has a new vector extension, just like AVX512. Even at Intel CPUs, you think they're CPUs, but if we compare, like, let's say 386 versus whatever Lake or Rapids, it's a completely different processor, not only architecturally, but the instruction set, the acceleration features are enormous, even though it's a CPU. So, but then also GPUs have become really general purpose. So it's no longer valid to consider GPUs as being special purpose. They're really general purpose. A little bit different type of computing model, but people can program GPUs fairly easily. They're a robust software stack. So it's all about software ecosystem, and there are some choices, like ARM x86, some GPUs with various programming models. But at the end of the day, it's really important to have a very stable software ecosystem, maybe combinations thereof, and then think about what can we extend, rather than to have some brand new customized acceleration, which may bring us 10 times speed up but have no software. So that's why I think GPUs and ARM can interplay very compatible.
Yeah, I'll the thing I'll add is that our collaborations already on things like one API, one DNN are yielding great results. For example, in one DNN, Satoshi-san's team did work that figured out how to use vector math to do systolic errors. And we took that and we productized it. Now, and it's available for everybody, whether it's AVX512 or anybody who has a vector engine can get additional performance because of collaborations like that. And similarly, we were just talking about all the auto vectorization work Intel does in our compilers, that we just put it into GCC and LLVM, and that could be taken advantage by that, right? And so to hit that 1000x that I talked about, this type of collaborations, figuring out what they understood with the machine, and some of the technologies in our roadmap that are coming up, like silicon photonics integration, for example, is super exciting for me. Some interesting caches, memory integration, and we would love to engage with folks like Satoshi-san to say how to build his next computer. So if he chooses an ARM or x86 or RISC-V or GPU or combination or something else, he should make that choice based on what's the right for the particular machine and the work.
Just as a note, we got #1 on the Cosmo flow on the new HPC MLPerf HPC benchmark, using being able to train this scientific AI code with 80,000 nodes on forgotten. But the underlying core of the training module is 1DNN.
It's 1DNN.
Which was done by Intel, but the ARM version we developed in collaboration with Fujitsu. So the ARM version of 1DNN is ARM making, but was done in heavy collaboration with Intel. So Intel is not just an x86, an area focused company now. I think they were very open to our collaboration in various ways.
And that's the new Intel under Pat's leadership, is the open, is our top order bet. It's the highest order bet, and we're going to lean in on that up and down the step.
This partnership and collaboration, do you have specific goals you expect to be sharing more about in the future? Raja, you want to take that?
Yeah, definitely. As Satoshi-san said, these programs are sometimes 10-year programs, and there are many technologies that we jointly look at and what makes sense. And when the time is right, if we land on some common collaboration point, we will definitely be talking to the world and announcing it and all that stuff. But it's more understanding the workloads, understanding what the goals are for next generation systems that we want to do, and we share our technology roadmaps with folks like Satoshi-san years in advance before we share with the rest of the world.
Great. Satoshi-san, Raja, thank you for talking with me today. Look forward to the next time. Take care.
Thank you, Tiffany.